50 years ago, pictures and videos of dinosaurs were of sluggish, slouching lizards lounging in pools and dragging their tails Godzilla style across the landscape. Today, it's all feathers and running and color. What's all this about? And how do we get from there to here? I'm Brad Potts, the dinosaur hobbyist, and this episode, Dino Feathers. A few weeks ago, Soundwave Senpai asked about dinosaur feathers in the comments. Do you have a question or topic you'd like covered? Make sure you comment below and help us out with a like. As the first dinosaurs began to be discovered and studied through the 19th century, it was apparent to naturalists and anatomists of the time that these remarkable animals were closely related to reptiles. Their diapsid skulls and teeth proved their close affinity to the group. With little more to go on than a handful of partial skeletons, their reconstructions and the image of them closely resembled the cold-blooded lizards they were thought to be similar to. The first to question this view was August Goldfuss, as far back as 1831. His discovery of a pterosaur fossil with fur-like covering was in conflict with the view that these were cold-blooded reptiles. It suggested an active animal with a warm-blooded metabolism, and as a close dinosaur relative, it implied they might be as well. These views remained on the sidelines, even as the early bird Archaeopteryx was discovered in a German quarry in 1861. Here was indisputably a prehistoric bird of the Jurassic. An anatomical comparison by Thomas Henry Huxley found many commonalities with theropod dinosaurs. Still, the idea that this or other birds were related to dinosaurs was rejected. It was believed that the birds were descended from some common ancestor earlier in the Archosaur lineage, not dinosaurs, and that some more primitive bird fossils would demonstrate this when they were found. For 150 years, those bird fossils would remain elusive. Reevaluations of the similarities between theropods and birds would again begin to gain traction with the work of John Ostrom, but the old common ancestor argument still holds sway over the community. That is, until 1996, with the discovery of Sinosauropteryx by Chinese paleontologists. Here, finally, was the theropod with primitive feathers that everyone had been looking for. Since then, the fine-grained fossil beds of China have been a goldmine of fossils preserving feathers and soft tissue, producing hundreds of feathered theropods from dozens of dinosaur genera, as well as birds. In 2007, quill knobs were found on Velociraptor, demonstrating that it not only had feathers, but that they were large, veined feathers like modern birds. And found in 2012, a 30-foot, 3,000-pound tyrannosaur named Eutyrannus. With this evidence and the development of a much more complete evolutionary history, it became clear that birds were just the descendants of theropod dinosaurs and can be placed in the family tree of dinosaurs close to the raptors, in the Avarostris group known as Paravis, which in addition to the birds, includes a number of non-avian theropod dinosaurs. So based on the fossil record, we know without a doubt that many theropods had feathers, either fully developed feathers or more primitive protofeathers. But what about T-Rex or Allosaurus? Did they have feathers? Well, Eutyrannus is an undisputed large tyrannosaur with feathers. And Nunaquasaurus, another tyrannosaur, survived in the cold, dark regions above the Arctic Circle. A woolly Tyrannosaurus? While there's no direct evidence for a feathered T-Rex, phylogenetics strongly suggests that all tyrannosaurs likely had feathers. So I guess But to change our Tyrannosaur from last episode, from this to this. How far back did it go with the oldest theropod feathers? At least 124 million years ago? And a common ancestor of known feathered theropods of at least 165 million years? Enter the Ornithischians. In 2002, a spectacularly preserved Psittacosaurus was smuggled out of China and sold at auction. In addition to the skeleton, almost all of the animal's soft tissue and skin had also been preserved. While negotiations went on for the return of the fossil to China, scientists studying the fossil discovered that the animal had bristles on the proximal portion of the tail. These were thick and rigid, but similar to the filaments found on theropods. Psittacosaurus was close to the base of the ceratopsian line. Could it have also had feathers? And if it did that mean that feathers went back to the beginning of Dinosauria, before Saurischia and Ornithischia split? In 2009, Xiaoting Zhen of the Shandong Tianyu Museum of Nature discovered a remarkable fossil of an early Cretaceous heterodontosaurid. Remarkable because this family represented the base of the line of Ornithischians, which led to duck-billed dinosaurs, ceratopsians, and pachycephalosaurs. That this basal group had survived 65 million years into the Cretaceous was remarkable. We'd call a living fossil today. But Tianyu Long Confuci had one more surprise: a fluffy proto-feather strip down his back. Driving home the final nail was the 2014 discovery of Coelindodurumos in Siberia. This 175 million year old fossil had extensive feathers. Its head and neck were covered with short filaments, its torso by longer filaments, and its limbs with complex protofeathers. This left little doubt. Ornithischians had feathers, so it was most likely that the earliest dinosaurs of the Triassic, before the Saurischian Ornithischian split, also had feathers. If that was the case, then it was likely that all dinosaurs had feathers, as it would be highly unusual for successor species to entirely lose this basal trait. But let's not stop there. Remember August Goldfuss and his furry pterosaurs? Some pterosaurs were extremely furry, with hair covering their entire bodies, like Sortus pilosus, the hairy devil. This hair appears to have been close to universal on pterosaurs, so it's likely that the earliest common pterosaur was furry. So far, scientists considered this to be a separate evolutionary innovation, a case of parallel evolution. In 2009, a name was given to these filaments: pycnofibers. Pycnofibers were short, simple structures with a canal running up the middle, and not deeply set in the skin like mammal fur. The new name was meant to distinguish them from mammal fur and dinosaur feathers. Pterosaurs are close dinosaur relatives, considered to be the most recent branch from the basal archosaurs before dinosaurs evolved. They have been grouped together with the dinosaurs in a group called Ornithoria. Two fossils from China would change everything. Again, the fine-grained fossil beds of China provided unprecedented preservation of the pterosaur specimens, along with their pycnofibers. What did researchers discover? 3 different types of branched filaments. The dermal fluff branches, that's a feather. One type, found on the neck, branched at the end in a brush-like manner. The second type, found on the head, had side branches. And the third, found on the wing membranes, branched from the base and resembled down. They were remarkably similar to the feathers found on many dinosaurs. The preservation was of such high quality that it was possible to sample the pigmentation of the feathers and determine that the pterosaurs were a gingery brown. It's possible that theropods, ornithischians, and pterosaurs all evolved feathers independently in a massive case of parallel evolution. But the simpler explanation is that feathers first evolved in the archosaur line around 250 million years ago, and that all these animals got their feathers from a common feathered ancestor. So what about sauropods? There is no evidence that they had feathers. Many skin impressions of sauropods, including those within eggs, have failed to turn up any feathers, not even baby fluff. The skin impressions found sample only a very small area of the animals, so this does not preclude the possibility that they may have had some feathers. With feathered ancestors, we may yet turn up a woolly sauropod. Similarly, Thyreophora, which includes the heavily armored ankylosaurs and stegosaurs, has yet to produce any fossils with feathers. It's quite possible that some groups of dinosaurs became secondarily featherless, which is to say they evolved to not have feathers. This has happened with mammals. Elephants and whales have both largely lost their hair. The other possibility is that we just haven't found this evidence yet. Just because we haven't found the feathers doesn't mean that there weren't feathers. What about feathers on crocodiles? They're archosaurs after all, and embryonic research indicates that crocodile scales form in a way very similar to bird feathers. The crocodile line split away from the archosaurs early, long before the dinosaur-pterosaur split, and before that feathered common ancestor. But it isn't impossible that we might discover a feathered crocodilian in the future. Perhaps modern crocodiles are secondarily featherless. Crocodiles were a widespread, diverse group with a variety of lifestyles and habits. Only one of those lineages got through the KT extinction event to be the ancestor of our modern crocodilians. So what were the early feathers used for? They weren't used for flight. There are two likely uses for feathers before they were co-opted by one line of theropods for flight: insulation and signaling. The furry coats on pterosaurs appear very much like they were used for insulation, and many of the dinosaurs, especially the smaller ones, might have used them for that purpose as well. Some large birds, such as ostriches that live in hot climates, use them for temperature regulation, actually protecting them from the heat. A big animal like a T-Rex likely used them in this way as well. The ceratopsians appear to have used them for signaling. The stiff bristles from the tail wouldn't have done much as insulation, but could have made the animal look larger to predators, deterring attack, or been used to signal mates, like the tail of a peacock. These questions of behavior are difficult to answer from the limited fossil evidence, though the ability to determine the color of fossilized feathers continues to improve and may provide more information in the future. In dinosaur news, a new species of dinosaur has been identified in South Africa after laying misidentified in the University of Witwatersrand's collection for 30 years. PhD student Kimberly Chappell led the team, which recognized the species was incorrectly identified as a Mastodontis, a common dinosaur in that region, when it was, in fact, a previously undescribed sauropodomorph. They named the new species Ngwevu Intloco, gray skull in the local Zoshi language. The new dinosaur has been described from a single, fairly complete specimen with a remarkably well-preserved skull. The new dinosaur was bipedal, with a fairly chunky body, a long, slender neck, and a small, boxy head. It would have measured 3 meters from the tip of its snout to the end of its tail, and was likely an omnivore, feeding on both plants and small animals. From the earliest period of the Jurassic, nearly 200 million years old, the Ngwevu is important as an early sauropodomorph and in showing the types of animals that survived the Triassic-Jurassic extinction event. Time for Comments with Timmy.
Kiefer Brown says, considering your interest in andrews, Bradley, I'd recommend checking out the book Dinosaurs of Flaming Cliffs by Michael J. Novak. Any idea which species of sauropod Andrews was referring to in that quote?
Thanks, Kiefer. I'll check out that book. As for the sauropod, it does not appear to have ever been described and named, but we can take a guess. I found 4 sauropods from the Gobi: Nemegatosaurus, Questatosaurus, and Ostacolicodia from the late Cretaceous and the early Cretaceous, Erkitu. All are titanosaurs, or close relatives. The Jurassic age that the team geologists gave to the rocks was based on the presence of sauropods, which at the time were thought to have gone extinct at the end of the Jurassic. The presence, though, of Psittacosaurus is diagnostic of the early Cretaceous. Somewhere in the collections of the American Museum of Natural History may lie the collected bones of Erkitu. If so, though, it would have to be an extremely large one to match Andrew's description. Don't forget to hit that like and subscribe, as it really helps out the channel. Check out our friends at CretaceousProductions.com for some handcrafted dinosaur plushies. And thanks to bensound.com for our music. I'm Brad Potts, and I'll see you next time on The Dinosaur Hobbyist.